Okay, Paul, you asked me to cover with you real quickly the proper charging procedure for the Maxwell supercapacitor. Well, today what I have here is your 16 pill, and it's all completed. And then I have your Maxwell supercapacitor. This will represent the charge line right here coming in from your charge system. Now I'm going to send you this light, which is just a standard automotive headlight, just a couple amps, and that's what we're going to trickle charge this capacitor with. You are going to put this light on the positive lead and then the other lead to the positive lead of the capacitor. Then you're going to hook up your little power, your multimeter that you must own. You're going to have to get a multimeter. I'm sure you have one at this point. And then you're going to apply power. Now you're going to notice this thing is going to be brighter than frickin' Hell's 80's ass as it pulls amperage across, and using this as a shock absorber to slowly trickle charge the capacitor. Please note this thing's been on for this entire period of time and we're still not even up to a volt yet. This light bulb you want to make sure is sitting upright and isn't away from anything that can melt, plastic or anything else, because it will get hotter than frig. Yes, this is on the low beam setting, by the way. And right now that light bulb is already up to 300, 400, 435 degrees. And you're just going to walk away, Paul. You're just simply going to walk away and let this thing charge for a couple minutes. So instead of standing here monologuing for a bit, we're going to let it run up to a volt, and then I'm going to walk away myself. And our official start time is approximately 27 after the hour. Okay, we're at 1.1 volt. Brighter than the eyes of hell, I swear is bright. So we'll be back in about 14.5 volts. I wanted to show this real quick. I grabbed my clamp over fluke ring and put it on there just to show how many amps is actually going into the capacitor as we slowly charge it. It's allowing 5.3 amps through at the moment. And we've been charging now for 3 minutes. And we're just now coming up on 3 volts worth of charge. Paul, the other thing that you got to keep in mind, bud, is that you charge this cap, this will get dimmer. Don't be deceived. That's why you've got to use a voltmeter to see what you got present on board inside the capacitor for voltage. And this is a one-time charge deal, Paul. You're going to put this thing on your setup, you're going to charge it. See, we're still brighter than holy hell here. We're still pulling 5.2 amps. And as we crest up towards the top, we get up towards the top of charging, the amp draw will start to drop down and the charge rate's going to go down. Like right now we're charging fairly quickly. We're at 3 volts now. We still have 13 more to go. We're going to fill this puppy up. We're going to fill up this can completely full of electrons. We've got it hooked up right now to a 16 volt or 16 500 amp power supply. It is sitting right at 16 volts. We're just going to let it sit here and do its thing. Alright, Paul, we'll be back here in a little bit. Okay, Paul, so patience is key here, buddy. Now, this thing has gotten about half as bright as what it was. And we're at about 8 volts now. About 10 minutes has gone by since we started charging. Come on, focus. There you go. About 10 minutes has gone by since we started charging. You just got to let it sit here and do its thing. We're pulling about 4 amps right now. And we're slowly climbing. But be patient. That's the other thing. This is a big, big capacitor, buddy. Very big. It's got a lot of electrons we got to store up on the inside of it. So don't get in a rush, because because if you get in a rush, you can damage the cap. So just let it go. We'll probably be about 20 minutes of charge time on this, so we'll be back. Okay, Paul. So you can see the light's barely illuminated. And we're now at about 13 volts. And once you get to this point, it's okay to go ahead and hook it back up. Now, when I send this thing to you, Paul, you've requested that I put a small 150 amp Anderson clip on this thing for you, which I'm going to do on the pigtail that attaches to the capacitor. But like I said, you can't be in a hurry. It's been 30 minutes now, and the thing is now within 3 volts of being charged, but on your truck or your automotive system that you're going to imply this thing into and put it into, it will be fully charged. This cap is going to represent like 5 extra batteries, literally, and it is going to smooth the voltage out in your whole system. You're going to be amazed. Your truck's going to start quicker. This thing is an amazing, amazing device. So that being said, we're going to cut this off. We're going to hook the positive leads from the amp up. We're going to bring this lead that comes from the 400 or 500 amp supply. We're going to hook it to here. We're going to bring it up the last remaining 3 volts. And next step, we test your amp. Let's get on with the show. Okay, now that we got the video out of the way on how to properly charge the supercapacitor, I want to take a couple minutes and let's take a look at the inside of this box. Now, Paul, when you talked to me earlier on the phone, you shared with me a couple concerns, and I wanted to talk about those things. First off, for those of you that have been following along on Facebook, you see that this has taken me like literally 2.5 weeks to do while doing a bunch of other projects, because I don't get to sit down and just work on one thing at a time. But what I do produce is a very clean, an incredibly clean little amp. We did our standoff, which supports the front end of the coil for the induction. I did vertically mounted capacitance tubes on this box, which was kind of fun. I used a 100 puff doorknob here, big KVA doorknob to be able to handle the amount of current that's going to be flowing by this thing. Just super nice and clean, everything perfectly neat and matched. Now we remoted this with some good wire, good coax. I like doing this style. It seems like it's worked out really well for me, having it elevated, not doing it over here, not doing the combiner port section back here. But the one thing that Paul asked me about is, he's like, well, I've seen you build them more rugged. And I said, what do you mean? He goes, well, on other amps I've seen where you've taken the wire and come over the top and directly feed the transistors. Yes, I have. Now, I covered this about a year ago when I had these developed for me and built for me. Back when I was still tinkering around with the 2879 base components, which I've more or less moved on from doing any R&D with these, because I think I've taken this as far as you can go. I mean, like, I've literally sharpened my pencil and gone as far as you can go. I had some problems with the standard transformer that everybody's been using. This is a pull that I pulled out of something and replaced with one of these. It's the only one I got like this, so it's not all shiny and pretty, and it's slobby solder work on it. This is what everybody used to use, and when I used to feed the transformers over the top, I was having induction issues with that. Like, if you notice, there's a dramatic height difference between the two transformers. Okay, so I wanted to increase its area above the board for allow more airflow around the transformer for cooling. That's the reason it sits higher. One of the reasons. Okay. The other thing I never liked was that this was bare. This back edge was bare, so when you set it down on the board, it could sit there and touch and arc out. I never liked that. Never, ever really cared for that. So I thought, well, the opportunity has come for me to design my own transformer. What are the things that I want to have done? Well, I wanted it elevated, which we did. The other thing I did is I wanted to have it insulated, which we did. I wanted to have my own part number on it, so you can't ever say that I didn't have these made. That's got a BBI number on it. I can track every single one of these transformers if I needed to. The other thing is I didn't like how the face was simply cut. I never ever enjoyed that. To me, there was always a risk of something falling in between here and getting caught, or when we assembled the box, that these might touch. I didn't like that. I wanted a solid face. I wanted the same material make, which is type 61, and I wanted elevated. Well, when I elevated it, it dawned on me, hey, what's the shortest distance between 2 points? It's a straight line. So I had them cut these little notches at the bottom. See the notches at the bottom of the transformer tab here? Okay, so when the transformer sits here on the pill strip, there's an opening at the front. You see the opening down in here? So now, with this not having a positive surface on here, and it having a little bit of phenolic as an insulator, I take my wire and I come off my bus bar, just like that, and I come to my pill strips. So each transistor is now fed with its own wire, and the transformer sits directly down onto the wire, and it doesn't allow any chafe point that can rub through or cause a wear that might cause a short. So instead of having to come up and over and then down to the transistor, it simply goes underneath. Now, the other thing is I used to put mirror boards, which is not new technology. It's something that everybody used to use back in the day, and it got eliminated because it added a little bit of cost to the box. I'd take a little piece of phenolic and I'd put it between the input transformer and the output transformer, and where that came from is when I first bought my spectrum analyzer, I was noticing that I was getting a funky little weird harmonic that was about half a principal away from primary signal generation. So about half a division away. And what was taking place was the wire that's on the input transformer was directly in line with the output transformer wire, and they were talking to each other across the component. And so when I was trying to find out how I could get more ground on the transistor, I put a piece of phenolic board down in between here that was notched out the same size as the transistors to carry a little bit more ground current. And then I noticed on the spectrum analyzer that that little harmonic had dropped out. And I went, oh wow, I figured out how to make the box a little bit cleaner. Well, when I wanted to elevate the transformer, as you can see now, this wire doesn't sit at the same plane or level as the output wire. And when I did that, the harmonic went away. Period. So I don't need to put the mirror boards in here anymore. Just saying. So, if we go back here and we look, we can see that each one of the transformers is fed with its own individual wire. It comes directly through and goes to the pill strip instead of having to come up and over, which looks good. I mean, like when somebody wants me to modify somebody else's box that doesn't have these transformers in it, the only other choice I have is to come over the top. Well, like I said, I had the opportunity to have these made for myself. I designed them so that they made sense for the way I build things. So now we've got an individual feeding for each one of the transistors. We have it in the shortest distances possible, and then we have it completely insulated and lifted above ground so we don't ever have to worry about it having a short. It's all in there. It's just this is like the last version of design that I'm going to do with the Toshiba 2879 based component, at least far as power distribution and hardware. Now, the other thing Paul asked me to do was to set this thing up so in the future he could expand if he wanted to, and he got a bigger charging system in his truck to go to a 24 pill. So we built this 16 pill in a 24 pill cabinet. He's going to get the 4 fans that you'd normally get for a 24 pill, but instead he's only having to cool off 16 components, which giving him an extra 4 slots, and only one side has got 8 transistors per side. So he's going to have a lot more cooling than what you'd normally have in a regular standard 16 pill, just because of the length of the heat sink. But I went ahead and I ran the power wires down the bus bar so that if we wanted to in the future, we could just drop in 4 transistors, change out the combiner, change out the splitter, change out the combiner, retune, he's off to the races and running. Quick, easy peasy, straightforward. This thing has turned out beautifully. And I've really, honestly taken my time putting it together. I haven't gotten in any kind of rush. And I'm done rushing, you guys. That's the other thing. Is I got so much work on my table and on my plate right now, I'm done. I'm done hustling through the builds, and I'm slowing down. And I'm taking my time and I'm enjoying what I'm building and working with each one of the customers. I have not taken a new order yet this year. Not at all. And until I can get the build time down to something that's a little bit more manageable, I'm not taking any new orders. I've got plenty of work. I've got a year's worth of work on my plate right now. Well, I get this one done and the one that's coming up after it done. In theory, in the book, that takes me down to 9 months. But I'm not going to take an order until I can get enough stuff out of the build book to where I'm less than 6 months behind. I just can't. I've got to manage myself and limit myself, and I know what I can do and I know what I can store. And the other thing is, every single time I take on a new build, I run right out, I buy all the parts for everything in the box, and then I got to sit there and store it for up to a year, which is a ton of shelf space, a ton of real estate, and a ton of room. I'm just saying. So I'm trying to cut back on that. But until I decide I'm going to take new orders, you're going to get to see a bunch of stuff like this come out. I've got a 48 pill coming, a 2x8 base unit coming that's going to blow your guys' mind. That's a combo unit. 16 pill, no 16 pill, 12 pill, 2x4, and a whole bunch of LD MOS stuff that is just sitting there crying at me. Dude, come build me. Okay. I love this ground strap that I added in here. Look at the solder work on that. Woo! Come out so pretty. Vertically mounted capacitance tuning once again. Now, you guys, I'm not a big fan of hot glue. I only like to use hot glue in 2 spots, and that's because it flexes. I don't like to, lock my tuning tubes in with hot glue. I use Captain tape, which has a very low dielectric to it, otherwise a very low conductivity. It's very heat tolerant. The epoxy or the glue that's used to make the tape sticky has a very high thermal cut, and it is very non-conductive to high voltage. Okay. Otherwise, incredibly low dielectric. I don't know if I said high or low. I mean low dielectric. It does not conduct worth a shit. It's like how do I put this? It's like the duct tape of high voltage and hot components is Kapton tape. It was developed for NASA, for us to go land on the moon. We built, if you go back and you look at the stuff when we were on the moon, the Kapton tape was on everything. And so is Mylar. They used Mylar on every goddamn thing. So, use Mylar with Kapton. It was amazing. That's what I use to lock my tubes in with, and it works really, really well. Those tubes are not moving, even though they're mounted vertically. Yeah, that's it. It's overbuilt to the nines, but because I've gotten to the point now where I've got this design down pat, and I've got these implemented. By the way, I sell these. They're $11 a piece. They're worth every penny. I love these things. There's 3 or 4 guys that are now starting to use these. They're going to totally fall in love with them. And I can handle anything that you guys can throw at me. Hundreds of them if you want. Makes no difference to me. I just pass them along, get them made, and send them on to you. But Paul, I poured a lot of energy and love into this thing. A lot of time, a lot of patience, and made a very clean and completely elegantly beautiful amplifier for you. Paul opted, he didn't want any screens on this thing other than the stock metal ones, so that's what we provided him with, and he wanted black fans, so we used the 2,200 RPM, double ball bearing, extra long life, Evercool fans. And this thing turned out titties. Well, this kind of feels like an unorganized mess to me, the way it's sitting here on the bench now. So what I'm going to do is I'm going to put the lid on this thing, Paul. I'm going to reorganize this thing, and yes, I'm using the bench 2x4 to drive this with. I'm going to reorganize this thing real quick, and we're going to get on with the testing. Paul, I hope you enjoy. Here we go. Okay. So Paul, Here's a 24 pill. It's completed. The warranty sticker's on it. I'm going to use the bench 2x4. And let's go around the lap real quick. It's a 1,000 watt slug in PEP, but in 5x position, so fully deflected, is 5,000 watts peak power. Now, you're going to look at that center scale, and you're going to add 2 zeros. That's a 5,000 watt slug in bird average. Once again, look at the center slug, add 2 zeros. 5 watt slug in reverse, back from the bird 10,000 watt dummy load. And the 2950 is what we're going to use to drive it with, since Paul, you said you don't have a 100 watt radio, and you said you're most likely going to just hit it with a straight 4. You're going to run at a little bit lower voltage than what we're running today, but I got to drive it to its max potential, because if it's going to break, I want it to break here. So you're going to probably end up loafing this thing along at about 3,800 watts all day long with a little 30 watt radio hitting a 4 pill. There's a 2950. It's a 5 watt slug showing the input tune going into the 2x4. The 2x4 out of line, we're going to be looking at the input tune going into the 16. Now guys, I did a video on Facebook and it's got a lot of response. It's a hot topic. I've had something like 2,000 plus views on the video that I did. I want to take a minute. I want to talk about the Maxwell supercapacitors. These things are neat. You're not stuck to this construct though. You're not stuck to this kind of frame. You can get each one of these cells individually and build your own. So you can stack up to any voltage you want. You can get them from Mauser. You can get them off Amazon. You can get them off, eBay. These caps are fairly cheap. I like the nice all metal design. This is a clamshell that fits around each one of the cells, which is a 1,000 farad capacitance cap in each one of these things, but they're 2.7 volts. So ultimately, I'm going to probably get myself a bank of these, and I'm going to build up to like 18 volts. Because remember, as you go up, your capacitance goes down. So instead of having the cajillion amount with the farad capacitance at 2 point some volts, when you start to put them up in series, your capacitance drops off quite a bit. That's the reason this is only 500 farad. Now 500 farad is a lot. We're going to do a couple tests here where we're going to charge the cap. I'm going to show you the inrush amperage, and then I'm going to show you the outrush amperage, and we're going to shut the power supply completely off. And we're going to run just off the cap. So we're going to run a 16 pill just off the storage in the electrolytic to show you how much energy is actually stored inside that cap. If you guys haven't noticed, I've gotten away from putting all the little capacitors. I got real famous for putting a huge bank of capacitors on the inside. That's before I even found these. As soon as I found these, quit doing that on the inside of the amp. Why? The primary purpose of a filtration cap like this is to resist AC current. Period. Okay? In this particular setup. But now that the storage capacity of the electrolytic components have gotten so vast, it allows us to move into a new state of operation with an electrolytic. Car audio guys have been using these for years and years and years and years. Like my Crown A6000 GTI I have in my pickup has got like 200 and something farads worth of capacitance built internally. A lot of the DB drag guys, the guys that show up to the DB competitions, they don't even have batteries in their trucks anymore, you guys. They just have big banks of capacitors. The problems with batteries is that they can only let go of amperage so fast. So it's got an outrush limit. Most batteries have an outrush limit of about 200 or 300 amps. Where this thing can give you all of its energy right now. So all 500 amps worth of storage that's in this thing, it can give it all to you right now. I mean, like right now. Where a battery can only let out 200 or 300 amps right now, but it can do that over a longer period of time. Well, you can offset that by having a bigger capacitor bank, and then you get more right now delivery time. If you go out and you YouTube this, you're going to find a video course that I put up about 4 or 5 months ago that I put one of these into a buddy's truck of mine, and he has had wonderful success with this thing. Absolutely loves it. I try to turn everybody on that calls me onto this capacitor. But like I said, you're not fixed in voltage. If you wanted to have one that did 13.5, you build up your capacitor bank, you drop one of the cells, which would drop you by 2.7 volts or 2.5 volts, and you'd be right where you wanted to be. Like I said, you can buy each one of the cells individually. You can get the shorting bars that go in between each one of the cells that have balancing boards on them to make sure that the capacitors are going to all charge evenly at the same rate. You can buy all that offline and build up whatever you want. Like I said, the car audio guys, the guys that have the SPL records right now, and they're burning up some serious amperage, you guys, have maybe one, maybe two batteries in their whole system. And the rest of it's all now done with capacitors. I mean, these things are a miracle. Absolute miracle. I mean, the 1 farad cans I had as a kid were huge. They were like that, by that high. Which really, they were like 2 farad at 24 volts or some shit. So they were 1 farad at 12 volt. You'd have to have 500 of those to equal what this thing can store inside of itself. That, to me, is impressive. Okay. So now, Paul, we covered the charging procedures. Now, Paul's got a 150 amp Anderson clip like this, and this is what he's going to try and run his electrical system off of. And he asked me to provide him with an Anderson clip that would clip right into his current electrical system. I said, not a problem. So Paul, the way you're going to set this up is you're going to bring your positive and your negative leads off the amplifier, and you're going to bring them to the positive and negative posts. And as you can see, I built the leads so they're staggered, and they perfectly marry up on these posts. Now, what I have envisioned in my head is that you've got this laying up against a wall someplace flat. I just took a guesstimation on the length of wire, so you can have a lot of real estate to move the amplifier wherever you want. Please don't cut these leads if you can possibly get away with it. I'm going to send the aught gauge lead with it. These eyelets I have gone and hydraulically crimped. I have a hydraulic crimper that crimps the end uniformly down on the wire, and then I drill out the end of the eyelet, and then I solder, backfill this with solder, and then they've been heat shrink. This is the best fit end that you'll get. If you cut these leads and go to some other kind of fitting, you're going to have loss. Just saying. Like I said, I am going to send the little automotive headlight for you to charge this thing with, and you're just going to track it up with the voltmeter. Okay, enough talky, more showy. So let's see, let's take this thing down to 1,000 watt scale. Let's show the input drive into the 2x4. Audio. About 15-20 watts. Turn on the 2x4. Audio. About 1,000 watts out. That's what's coming out of the 2x4 going into the 16 pill. So, with 20 watts worth of drive on 16 volts, here's your input tune. See how it's falling back, Paul? So as you increase your drive level, the reflect from the amplifier goes down, which means it's falling into resonance the more wattage you put into it. So, 600 watts, pardon me, about 500 watts, and how much bird? 300 bird, with only 20 watts of drive. We're going to kick that down to 5x. We're going to turn on our 2x4, which is not running on this setup, by the way. This is running on the bench power supply. It's running at 14 volts. We're at 16.5, fully charged, maxed out. It's a 1,000 watt dead carrier. Swinging over to about $5 grand, no problem at all. Let's look at the average meter. About 2,200 on the average bird meter, no problems. We're about 25 out of it that time. So 2,500 bird. Let's look at our volt readings here. Amperage. short of 300. 286, I do believe. So, as it slowly charges itself back up to full potential, we'll wait until this gets to be about 3 or so amps. So there we are, full potential now. So I'll shut the fans off. We can even meter the load of the fans. 1.4 amps. So 380 amps on the output side. Now let's measure the input side. Audio. You guys see that? 280 amps on the output side. See how it's charging now? So where most of the current is actually coming from, it's not coming from the lead from the charge system. Only about half of the load is. The rest of it's coming out of a capacitor. Scooching cool, right? So let's double verify that data. So, like we just verified, the fans are going to pull about 1.2 amps, 1.7 amps. 0 amps. Turn the fans back on. Most of the work is getting done here. Meanwhile, the electrical load shock that's being applied to the charge system of the vehicle, i.e. your alternator and your other batteries and stuff, has been cut by half. Instead of seeing the full brunt of 300 amp worth of load, it's only seeing about 100, 150. And it's real slow. If you can measure how the load comes onto the electrical system on the vehicle, this is real slow. It applies the loads really slow because the capacitor is taking up the gap. Cool, right? So, amp meter shut off. We're going to zero that. So I want you to see something. Now this is on the input side. I'm going to go down here, shut the power supply off. We're running strictly on the capacitor. There's no amperage coming from the charge lead whatsoever, and the amplifier is still running. There's still 13 volts worth of current inside the cap. Or not current, 13 volts worth of voltage. And if we wanted to do the quick math, we could figure out how many amps are left inside the cap. So now we're going to charge it. Look at those numbers. I saw 300 and something there for a second. So let the cap charge back up again. Just in case you guys missed it, we're going to do it one more time. Okay, so the cap's fairly full at this point. We're back up to 16.5. We'll level off at 16.57. So it's pulling just a little bit of current. Shut the power supply off again. 0 amps. BBI, the voltage is dropping. Yep. Because as we're sacrificing the volts to create the amperage, our watts are going to come down. Hello, 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 hello. Time to come off the key. Alright, so let's charge this up again. 486 amps in rush currents. That means it had to dump 500 amps worth of current out of that little tiny can, which is tiny. I mean, it's just a little bit bigger than the 2x4 in length, to run this box, and it ran it all by itself. So we're going to come back over, we're going to clamp on the output side, let this get back up to full charge. Shut the power supply off again. We're going to hit it with a load. Audio. I got to come up off the key because I go below 11 volts and I possibly can damage the component, i.e. the $65 a piece transistors. So we're charging now, and these leads are moving. Every time I kick that power supply on, it's able to jam out 500 amps worth of charge. We're only pulling the fan current. See that? This is the neatest measurement of them all. This is like the... Oh, bump the record button. This is like the seller of the seller's button right here. Check it out. 300 amps on the output. Audio. 186 on the input side. Audio. Meanwhile, we're over here just still banging out the juice. 2500 per. Consistently through this entire time, testing it over and over and over and over again. Now, Paul, you were a little worried about heat. I'm telling you, I can put my hand right on the back of this, and it's not even lukewarm yet. None of the connections are warm. Nothing's getting strained. Nothing's hot. Where's my FLIR? FLIR. Those are the eyelets. No warmth there. And what we're seeing is a shiny reflection of the light directly above it. There's no heat on any of these connectors. It means you're getting good conductivity through them, and they're not acting as resistors. Paul, that's it, man. I've poured 2 weeks worth of love, time, energy, effort, and I built you the cleanest 16 pill I could build you with all the upgraded components that I could possibly give you. And I think right now you're kind of kicking yourself because I think the electrical system you have in your truck could probably support this thing as a 24 pill with one of these caps. And I'd be damn positive behind it if you bought 2 of these caps and we put them in parallel, because the capacitor does the work, and in between the keys your alternator charges the caps. This is neat stuff, you guys. Buy one and try it. It'll blow your mind on how much better your shit works in your system, especially when there's zero amperage restraint and 0 voltage restraint getting delivered to the components. You don't have to run at 16 volts. Its top voltage is 16.5. Okay? You can run it at 14. You can run it at 13. It will hold the charge at its maximum amount of capacity at whatever voltage you feed it, up to 16 volts in these pre-made enclosures. I have a 48 volt and a 24 volt version of these. Guys, my name is BBI. There is some more cool tech coming out of this shop every single day. The rest of these guys are going to be like, oh yeah, I played with that and know all about it. No, they didn't know anything about it. No one had a clue about this till I came out about 8 months ago and started dropping this into the radio world. But at that time, I wasn't able to do a full up and load test video. We've seen a single Maxwell 500 farad capacitor run a 16 pill all on its own, completely on its own, at 5,000 watt output for seconds and seconds and seconds and seconds at a time. That says a lot, and I mean it says a lot. Paul, enjoy. Gentlemen, I'll see you guys. I'm out of here. Come check me out on Facebook, Twitter, Instagram, Snapchat. You Gargler, like right here, YouTube. Click the subscribe button, because I'm always doing cool shit like this. I mean, you never know what's going to happen next. I've got a beautiful 2x8 I got to do and a 48 pill that's coming up here in this next week. I'm going to start. It's going to take me probably about a month to build it. Good stuff. Appreciate y'all tuning in. Paul, amp number 2037 done. And you're in the done pile, my brother. It's on its way to you tomorrow. I'll see you. Bye-bye.